Let's look at an example of how a connection is created between two pieces of user equipment, or UE, in 3G Release 4. The most significant change from 3G Release 3 is the separation of the control plane and the user plane. The control plane is the array that call control data is carried over when establishing a connection between two pieces of user equipment. After the connection is established, communication goes through the path set on the user plane. In this example, call setup between two mobile phones is established using the non-tunneled backward bearer establishment method. Call setup begins when the call is initiated. The process of establishing the user plane begins with network side bearer establishment. Then access side bearers are established. Once the call is connected, the conversation is held along the user plane. When the call is initiated, the network needs to determine whether user A will be allowed to use the service being requested. A setup message is sent through the Radio Network Controller, or RNC, to the MSC server. The Mobile Services Switching Center server, which is also called the MSS, receives and authenticates the user to ensure that the requested service is valid. Once authenticated, MSSA signals the RNC to proceed with the call. After the call is cleared to proceed, the MSS selects the Multimedia Gateway, or MGW, that will be used for the call. This is the gateway through which the Backbone Network Connection, or BNC, will be established. In order to establish the BNC, the MSS must acquire network side bearer termination reservation and bearer information from the MGW. The MSS initiates a Prepare BNC Notify transaction by sending an address request command to the MGW. The address response command returned to the MSS includes the BNC ID and the context ID supplied by the MGW. Communication between the MSS and the MGW occurs using the H248 protocol. The BNC ID is the unique identifier for user plane connectivity on the ATM core network for the call setup in progress. So both MGWs will use the same BNC ID for network side bearer establishment. The MSS performs a routing process using call control analysis to determine the destination of the call setup. In this example, the destination is the Home Location Register Inquiry. This results in user B's mobile station roaming number, or MSRN, being returned to MSSA. Then digit analysis is performed on the MSRN to determine the final destination, which in this example is MSSB. The initial address message, or IAM, that is sent to MSSB contains the called party's number, which is the MSRN in this example, the BNC ID, which is BNC ID1, the address of MGWA, which is 3586010002, the action, which in this example is backward bearer establishment, and the transport type, which is AAL2 in this example. Communication between the MSC servers takes place using the Bearer Independent Call Control, or BICC protocol. MSSB performs digit analysis on the received MSRN to determine its destination. Then user B's phone is paged to determine its availability to take the call. A confirmation message is returned to the MSS if the phone is available. If codec negotiation needs to be performed, MSSB sends an Application Transport Mechanism, or APM, message to MSSA. The APM message contains the codec selected by MSSB. The MSS and the MGW perform a Modify Characteristics transaction in order to confirm the codec to be used in the MGW. The MSS initiates the transaction by sending a Modify Request command to the MGW. The MGW acknowledges the request by returning a Modify Response command. As soon as MSSB sends the APM, it selects an MGW for the current call setup. Then MSSB performs a Prepare BNC Notify transaction with MGWB. During the transaction, MSSB requests a termination ID on the network side. MSSB also requests a context ID for the BNC ID generated by MGWA. Now MGWB begins bearer setup towards the calling party's MGW. It knows which MGW to contact because it received MGWA's ATM service endpoint address and BNC ID during the Prepare BNC Notify transaction. The ATM service endpoint address is also known as the bearer address. MGWB sends an establish request or ERQ message in order to establish a connection with MGWA. The message is sent using the ATM AAL2 signaling protocol. The calling party's MGW responds with an established confirmation message, which is also known as an ECF. The ECF message confirms that the user plane has been established between the gateways. Each MGW notifies its respective MSS that bearers between the gateways have been established. They do this by performing a BNC established transaction, which is initiated by issuing a notify indicator command. The MSC servers respond with a notify response command. Now that the BNC has been established between the multimedia gateways, MSSA needs to manage the creation of an access side bearer between RNCA and MGWA. In a prepare BNC notify transaction, the MSS issues an address request command containing the context ID of the network side bearer termination. The MGW returns an address response command containing the gateway's termination ID and its context ID for access side bearer termination. The MSS now sends a radio access bearer or RAB assignment request to the RNC. The RAB assignment request contains the binding reference BNC ID and the bearer address it received from MGWA during the prepare BNC notify transaction. The RNC examines its resources to determine whether it can continue with the call. Then it reads MGWA's bearer address and executes digit analysis. The result of digit analysis is that RNCA has a destination for establishing a bearer connection. MGWA receives an ERQ from RNCA in order to establish a bearer connection. The MGW confirms by returning an ECF. Then RNCA sends an RAB assignment complete message to MSSA, informing it that the access side bearer connection has been established. The calling side MSS sends a continuity message or CORT to inform the succeeding node that it is ready to continue with the call. The called side's MSS begins the process of establishing an access side bearer by conducting a prepare BNC notify transaction with the MGW. Then an RAB assignment request is sent. Once the access side bearer is established, an RAB assignment complete message is sent to the MSS. Notice, however, that network and radio access bearers on MGWB are not yet thoroughly connected. After both access side bearers are established, the call is ready to be connected. First, the called party's RNC sends an alerting tone to the MSS. Meanwhile, user B's phone begins to ring. When MSSB receives the alerting tone, it sends a modify request command to MGWB instructing it to play a ringing tone. As a result, the MGW reserves resources to play the tone and returns a modify response command to MSSB. Then the ringing tone is generated in MGWB and sent through the user plane connections towards calling party. When MSSB receives the modify response command from MGWB, it sends an address complete message or ACM to MSSA. Then an alerting message is sent through RNCA to the calling party's phone, from which the user can hear a ringing tone. When user B answers the phone, a connect message is sent through the RNC to MSSB. The MSS sends a modify request command to MGWB asking the gateway to stop playing the tone. The command also requests that MGWB connect the backbone termination to the radio access termination. The gateway acknowledges the request with a modify response command. After receiving acknowledgement from MGWB, MSSB sends an answer message or ANM to the calling node. Then MSSB sends a connect message through the RNC to user A's phone. The resulting phone conversation takes place along the user plane. Now let's look at the call release process as outlined in 3G Release 4. The call release process ensures that network resources are freed so that they can be reused. In this example, user A terminates the call, which sends a disconnect message to the radio network controller or RNC. The RNC forwards the disconnect message to the mobile services switching center server, which is also known as the MSS. Then the MSS sends a release or REL message to the succeeding node. After the release message is sent to MSSB, each MSS begins to release resources on its side of the connection. First, an REL message is sent to the user equipment. The release of resources on the user equipment side is confirmed by returning a release confirmation or RLC message. The next stage in the release process is to release the resources that the RNC is used for the bearer connection. Each RNC issues an IU release request. The MSS responds by returning an IU release command. Then the RNC releases the resources and sends an IU release complete message. After the RNCs are released, each MSS issues a subtract request command to the MGW on its side of the connection. This releases the termination that was established for the access side bearer connection. Each MGW returns a subtract response command, which confirms that it has released the terminations. Then MSSB responds to MSSA's REL message with a confirming RLC message. Finally, each MSS issues a modify request command to its respective MGW. This time the result is that the MGWs release the resources used for the network side bearer connection. Then the MGWs return a modify response command and the process is complete.